Hey, it's Jillian. We're going to go through similar triangles. So earlier we talked about congruent triangles and similar triangles. Now we're just going to focus on similar triangles for this exercise. And similar triangles are, of course, exactly the same angles are corresponding. So these angles will be equal, these angles will be equal, and these angles will be equal. And these sides won't be equal in length, but the ratios will be equal. This divided by this will equal this divided by this will equal this divided by that. So let's get busy and see what's going on here. It says, in the similar triangles ABC and DEF, determine the measures of the side lengths and the measures of the unknown angles. So we know that if that's 37, A is 37 degrees. We know that B is 53, we were given that. We know that C is 90 degrees, we were given that. We know that D is 37, we were given that. E is corresponding to B, which is 53, and F is 90 degrees. So that was pretty easy. Now let's take a look at the lengths of the sides. So here, we're going to call these 1, 2, 3, 4. That's 4. So AC is 4 units. C to B is 1, 2, 3. And then we can't count on the grid, so when you have two sides of a right angle triangle, you know that you can use Pythagorean theorem to find the third side. So some of you know your Pythagorean triplets. We'll talk about that in a minute, but let's just solve this the usual way. So we have here 3 squared plus 4 squared equals, we don't know what squared. Actually, let me write the line before it. So it should really be that BC squared plus AC squared equals AB squared. So that's 3, that's 4, and let's just go back to calling this AB. Okay, so now that's 9, that's 16, that's AB squared, whatever that may be. Now we've got that equals 25, AB squared, and what squared is 25? Well, we know 5 squared, so we're square root both sides, so we've got 5 equals AB, and of course we can write it as AB equals 5. So AB equals 5. You're going to learn about Pythagorean triplets and what numbers go together for the three sides of a right angle triangle. 3, 4, and 5 go together, as long as 3 and 4 are, of course, not the hypotenuse, and then 5 is the hypotenuse. So these sides are always smaller in length than this, so it would be 3, 4, 5 or 3, 4, 5, but this has to be the 5, the hypotenuse, the side opposite the angle. Okay, so now let's take a look at this. We've got DE, can't count, so we're going to count on the grid for EF. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, EF. DF is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now when we solve for DE, let's do it like this. DF, EF, and DE. So DF is 12, and EF is 9, and DE is, we don't know yet. So that's 144, that's 81, and that's DE all squared. So that plus that is, that's 5, that is 2, carry the 1, that's 225. And the square root of 225 is 15, or 15 squared is 225. So DE equals 15. Now, how do the measures of the corresponding angles compare? So let's see. How do they compare? Well, just like I said, they're exactly the same. They are the same. Find the ratio of the lengths of the corresponding sides. So let's see here. AB is 5 and DE is 15. BC is 3 and EF is 9 and AC is 4 and DF is 12. So let's see, what happens when we reduce these fractions? The ratios of the corresponding sides compare again. They are the same or they are equal. So now we're going to calculate the area of each triangle. So we know the area of a triangle. The area of a triangle is 1/2 base times height, or maybe you learned it as base times height over 2. That's the same because you know dividing by 2 is the same as multiplying by 1/2. So let's plug it in and see. So we're going to see, so the area of triangle ABC is 1/2, and the base was 3, and the height was 4. So 3 times 4 is 12, and half of 12 is 6. So 6 units squared, whatever the units are. Now the triangle, the area of triangle DEF is, of course, 1/2 base times height, which is 1/2 9 times 12. So let's see, what's half of, can't take half of 9 nicely, so let's do half of 12 is 6, and 6 times 9 is 54. So let's now find, I forgot my units. Let's now find the ratio of the areas. So 6 over 54, well, 6 goes into 6 once, and 6 goes into 54 9 times. So how does the ratio of the areas compare with the ratio of the corresponding sides? Well, this squared is this, which makes sense because area is a square. So we have the, I'm just going to put it up here because I'm short on room. So the area of the, let me write it like this. Actually, I'll write it like this. Area of triangles equals the ratio of area of triangles is equal to the ratio of the sides squared. The ratio of the area of the triangles is equal to the ratio of the sides squared. Okay, so in summary, let's take a look at this. We have